This is the brief on wave equation principles and wave splitting dynamics. We're going to boil down the core physics of waves, how a simple force balance is what actually creates them. And what's really cool is how that initial bit of energy, the way you start it, dictates the exact shape and direction the wave travels. Okay, first takeaway. For a 2D wave, like on a vibrating drumhead, the key thing to get is that the wave shape, its local curve, well, that is the restoring force. So even though tension is pulling along the surface, that net vertical force that makes it pop up and down, it perfectly matches the curve at that exact spot. It's pretty amazing. The geometry itself is what's driving the wave. Second, let's talk about how you start the wave, because that changes everything. So picture a string. If you pull it up and just let it go from a dead stop, it splits perfectly, symmetrically, into two identical waves going in opposite directions. But if you keep the string flat and instead you hit it, giving it an initial velocity, it splits into a positive peak going one way and a negative trough going the other. It all comes down to how you put the energy in. And finally, let's get real. We have ideal waves versus realistic ones. An idealized undamped wave, it's perfect. It just keeps its height forever, never losing any energy. But in the real world, you've got damping, energy loss, and that makes the wave's overall height shrink and shrink exponentially until, poof, it's gone. So, from the initial energy to the restoring force, understanding how a wave starts is absolutely essential to modeling how it's going to behave, whether it's ideal or real.